Hello everyone, welcome to my channel Euclid Mathematics. In my today's video, I will explain to you all a topic example from real analysis which asked in CSIR NET December 2018, which is a single selective question. It asks for the 3 marks. Okay, so let's read our question and then we see how the answer is look like. Okay, so here the function is given fn from domain to codomain. It is given to close interval 0 and it is given. Okay, and given by f1 of x function is given to minus x raised to n, all non-negative integer n. Okay, so all integer are non-negative, and if limit n tends to infinity fn x which is equal to fx given, it is uniformly on interval 1x 2. Okay, then we have to find out which one of the following option is true. Okay, so first option it says that f is a continuous function on close interval 1 2. Second is converges uniformly on f on close interval 1 2 as n tends to infinity. Third option it says that limit n tends to infinity 1 to 2 fn x and dx which is equal to integral over 1 to 2 fx dx. Okay, and fourth option it says that any value a from open interval 1 to we have the limit n tends to infinity fn dash of a which is not equal to f dash of a. Okay, so we have to figure it out which one of the option is correct. And now our first task is here we have to check whether the function is continuous or not. Okay, if the function is continuous then we have to proceed further. If it is not continuous then these properties are going to be wrong. Okay, now let's go for the solution of our example. Okay, so we can see that in our example which is given fn x is equal to 2 minus x raised to n. Okay, fn x is given to minus x raised to n, and when we apply the interval, okay, interval is given for first continuous interval for 1 to 2. Okay, so option A it is say that if it's continuous on interval 1 to 2, okay, close 1 2. So we have to check, and for value for x is 1 and for x is equal to 2 as n tends to infinity to our fn x, then if it is gives equal value finite exists then function is continuous. If finite exists not equal then function is not continuous. If function is not continuous then not uniformly convergent. Okay, so let's go for the it's a continuity of function. So you can see that limit n tends to infinity fn x when we apply, okay, when we apply limit n tends to infinity fn x, we can see here 2 minus x raised to n as n tends to infinity when x is a 1. Okay, so we have interval 1 to 2. Okay, close 1 to 2. That means x contain the value 1 and as well x contain the value 2. Okay, so at the end point when x is a 1 and n tends to infinity, okay, x is 1 means 2 minus 1 is 1. Okay, and 1 raised to infinity, that means 1 raised to any power, it remain 1. Okay, now let's go for the x which is equal to between 1 to 2 but not included 1. Okay, because we found the value for x is 1 but we do not want the value for x is 1 here. Okay, so we have to check the remaining value other than 1 what we get the our function, what our function gives to us. Okay, so we can see that fx is a limit n tends to infinity to minus x raised to n and the values between 1 and 2. Okay, so you can see that the value here for x which is between 1 and 2. Okay, and when we subtract it from 2 we get the smaller value than 1. Okay, so that means if we consider 1 by 2, x is 1 by 2 here, and 2 minus 1 and 1 half. Okay, that means 1.5. If we consider x is 1.5, that means 1 into 1 half, that means 3 by 2. That value 2 minus 3 by 2, it gives the value smaller than 1. Okay, and when value is smaller than 1 and when we apply n tends to infinity smaller value, then it goes to the 0. That value approaches to 0. Okay, then you can see it here. So our function gives finite values 0 and 1 which is exist but not equal, and if it is not equal then it is not continuous, and if function is not continuous then it means that that function it is not uniformly convergent. Okay, so we see here fx is not continuous on 1 close interval 1 to 2 and fn x is not uniformly convergent on close interval 1 to 2. Okay, but make sure that if we change that interval, might be some other interval are there that gives our function is continuous as well as uniformly convergent. Now let's verify the option, which one of the option is correct here. So f is continuous on close interval 1 2, it is wrong. Uniformly continuous convergent on close interval 1 2, it is also wrong. Okay, now the leftover option it is here C and D. Now we have to figure it out which one of the option is correct here between C and D. Now let's verify which one of the option is correct. So in option number C it says that limit n tends to infinity integral over 1 to 2 fn x dx, okay, which is equal to integral 1 to 2 fx dx. Okay, so these two values are equal which is given in our option number C. So we just have to find out the value for integral. Okay, so we have to find out the whether these integrals are equal or not. Okay, so it is quite easy to find out their integration. Okay, limit n tends to infinity 1 to 2 2 minus x raised to n dx. Okay, this is the value for fn x. Now integrate it, so we can see that x raised to n, integration of x raised to n is x raised to n plus 1 upon that n plus 1. Okay, now you can see it here. They apply the integration, we get the minus 2 into x raised to n 2 minus x raised to n plus 1, okay, n plus 1 upon n plus 1 into upon differentiation of 2 minus x is also there, okay, because this is a function of f of x form. So minus x has differentiation minus 1, so it goes to minus here, okay, and apply limit n tends to infinity here. Once we apply limit n tends to infinity, okay, so you can see it here, we get the value for 1 upon n plus 1, okay. How it is 1 upon n plus 1? For that, apply here as a end point, okay. So if we put x as a 2 minus 2, it is a 0, okay, because we integrate with respect to x, okay. So we have to substitute the value of x as a 2. So 2 minus 2 is a 0. So first term it gets to 0 for the 2. Now second term minus of x, which is equal to 1. So minus minus it get plus, and x is a 1. So 2 minus 1 is a 1. 1 raised to n plus 1. It remain always 1, okay, and n plus 1 it is here, okay. This is a substitution of that limit in our integral. So limit n tends to infinity 1 upon n plus 1, okay. So when we apply n tends to infinity to our f 1 upon n plus 1, so 1 upon infinity it gives 0. And other integral it says that 1 to 2 fx dx is a 0, okay. Now check it out directly, the integral for fx dx, okay, it is 0 or not. So here we can see here, when we apply limit n tends to infinity 1 to 2 fx dx, okay, so we apply fx limit n tends to infinity fnx as n tends to infinity, we get the value, it is a 0 here, which is in the interval of 1 to 2, okay. So exactly that value we want it here in the option number C. So you can see option number C, the value for 1 to 2 fx dx, it is also 0, and this one is also given 0. That means both of the values are equal, and if the both value equal, that means our option number C, which is a true, okay. So here, that means in option number C, limit n tends to infinity 1 to 2 fnx dx, we got it 0, and integral 1 to 2 fx dx, it is also 0. So option number C, which is a true. Now check it for option number D. We have to check when we take differentiation, n the differentiation of a, fn dash of a as a limit n tends to infinity, which not equal to f dash of a, okay. So that means we have to differentiate it only, okay. So it is easier that to differentiate it, apply limit n tends to infinity, and when we get that, to check out whether it is equal or not, okay. So option C is correct, then option D is wrong here, okay. It is single selective answer, so it is only one option true, okay. So I hope so you all have understood my today's lecture on a question from CSIR net. For similar question, you can check it my playlist. I uploaded more videos there. That if you need any help, you can ask me in the comment section also. So thank you everyone. Thank you for my today's lecture.